Hello students, and welcome to the second video of this lesson. In this video, what we're going to be doing is we're going to be looking at a graphical approach to understanding the connection between f and f prime. We have one more video following this, so make sure you stay tuned. But let's get started in this one. So our first part says, all right, we want to approximate the value of f prime of 4. So when I'm approximating the value, it's not always easy. So a good method is to think about, all right, the slope of the secant line. All right, so if I want to find f prime of 4, let's see, that's going to be 1, 2, 3, 4. So that's going to be this point here. Well, what I can use are the 2 points around it. So 3 and 5. So let me write down those two coordinates. So I have 3, -1, and I have 5, 4. So how do I find the slope of that secant line, the point that connects, or the line that connects those 2 points? Well, that's just going to be y2 minus y1, so 4 plus 1, over 5 minus 3. And so let's see what I get. I get 5 over 2, and that's going to be the slope of my secant line. So f prime of 4 is approximately 5 halves. And so let's think about this. So the perfect secant line, or the perfect tangent line, would be something close to that. And what I end up finding here by connecting the 2 points that I'm looking at right here is that. And so notice how similar, how close those slopes are. And so that's why it works out to be a pretty good approximation here. Now from my graph, I want to see what values of x is f prime of x equal to 0. And we want to justify our answers. Well, f prime of x equals 0 when f of x has a relative max or min. So what points am I have a relative maximum or minimum? So the points that I have that at are x equal to -4, x equal to 1, and x equal to +5. Those are the points where I have maximums and minimums, and so those are the points where f prime would be 0. Again, we're looking at the slope of the tangent line there, so that's going to be 0 right there, 0 right there, and 0 right there in the graph. Now I want to think on what open intervals is f prime of x less than 0. So let's think about what f prime of x equals or is less than 0 means. Well, what does that mean for us? That means that f of x, sorry, I wrote f prime, but I meant to just write f of x. So f of x is decreasing. So where is my function decreasing here? Well, it's decreasing in between -4 and +1. And it's also decreasing between 5 and infinity. So those are going to be where f prime is less than 0. And notice how we're getting information about the derivative, but all we have is the graph of f. So in a similar note, we want to see, okay, when is f prime of x greater than 0? So f prime of x greater than 0, that means f of x is increasing. All right, so it's increasing. So what are the intervals where that's doing? So if you go up and you look at your graph, that's going to be -infinity to -4, union 1 to 5. Those are the points where f is increasing, and so we can determine that f prime is going to be greater than 0. It's going to be positive. So now I want to say, okay, what values of x does the graph of f prime go from below the x-axis to above the x-axis? So when is it switching from below or from negative to positive? Okay. And again, all I have is the graph of f, but with the knowledge that we've gained so far, I'm able to create insights into f prime. So what do I want to say here? Well, I want to say that f prime of x is changing from negative to positive when f of x changes from decreasing to increasing. And in this case, it occurs at x equal to 1. So in a similar regard, I want to also say the values of x where f prime is going from positive to negative, where it's going from above the x-axis to below the x-axis. So where's that happening? Well, we can justify this by saying f prime of x changes from positive to negative when f of x changes from increasing to decreasing. And in this case, that's going to occur at x equal to -4 and x equal to 5. So in this problem, in this case, we're going to switch things up a little bit. We're going to try to answer questions about f of x, but this time we're given f prime. So it's the exact opposite of what we were given last time, but you're going to notice that we're able to dive into answers the exact same way. So in our first question is asking on what open intervals is the graph of x increasing? So we want to think about when f of x is increasing. So f of x is increasing when f prime of x is greater than 0. So when f prime of x is positive, we know that f of x is greater than 0. So from this graph that we have, we only need to figure out where is it positive. And that is occurring, which occurs on -3 to -2. So on those x values in between -3 to -2, the graph is positive. So on that same vein, we want to say on what open intervals is the graph of x decreasing. So f of x is decreasing when f prime of x is less than 0. And so when is this happening? So you might look at this graph and say, okay, it is less than 0 between -2 all the way over here to 4. But that's not necessarily true because at 2, it's equal to 0. And we're not saying when is it less than or equal to 0, just when it's less than 0. So we do have to take that 2 value out of our answer. So it occurs on -2 to 2, union 2 to 4. So that's how you can take that possible 2 where it's equal to 0 out of your final answer there. Now from our graph, we want to see at what values of x does the graph of f of x have a horizontal tangent? Well, we have a horizontal tangent when f prime of x equals 0. So when is f prime equal to 0? Well, that happens when x equals -2 and x equals +2. So that's where the graph has horizontal tangents, the graph of f. And now we want to say at what values of x does it have a relative maximum? So f of x has a relative maximum when f prime of x changes from positive to negative. So when is that happening in our graph? Where is the graph changing from positive to negative? That is happening when x equals -2. So now we want to say what values of x does f of x have a relative minimum? Well, f of x has a relative minimum when f prime of x changes from negative to positive. So where is that happening in this graph? Well, it actually never changes from negative to a positive. So f of x has no relative minimum. Now we want to say, what is the slope of the tangent line to the graph of f of x at x equal to 0? Well, the slope of the tangent line means derivative. We're given the graph of the derivative. So the slope of the tangent line at 0, we just look at the graph at 0 and we give that value, that f prime value. The slope of the tangent line at x equals 0 is -2 because f prime of 0 equals -2. Now we want to do something similar with the normal line. So what is the slope of the normal line to the graph of f of x at x equal to 4? So again, let's start with the tangent line. So the slope of the tangent line at x equals 4 is going to come out to be -2 because f prime of 4 is equal to -2. So the slope of the normal line is going to be the negative reciprocal, which is 1/2. that's going to conclude this video here. In our next video, our final video for this section, we're going to look over how are we going to apply what we've learned about graphs of derivatives and the connection between f and f prime, and how are we going to do that when we're not given a graph? How can we do this analysis in a similar way when we're just given the function? So I'll see you guys in the next video. If you have any questions in this video, go ahead and reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.